and in array there is some element, and we have to calculate the majority element, means the number of that element. If that number of element is greater than n by 2, then that is then return that element. Now how will we approach? First with brute force. In brute force, first we will count for one element. For this element, how many one is there? One, two, three, four. There are four number of ones, and then we will count for second element. Also, second element is one, so we will also count for this ones. So four number of ones. This is our brute force approach. So we will take every possibility. Then we will count for two second number of for second number. For second, so there are one, two, three. Second number is three times. Also, this is two, so two number is also three, and something like this. After completing this loop, we will check if a number if or if an element is greater than n by 2. Hence, this is must be greater than half of element in array. So if that happen, then that element will be returned. Then return number of that element. So let's see for our brute force. In brute force, first we will take for loop for int I is equal to 0 to n minus 1, and there will be a inner count. This is a local scope and count will be 0, and another loop for int j is equal to 0 to n minus 1, and then check if array of I is equal to array of j, then count plus plus. After this loop complete j, we will check if count is greater than n by 2, then there is no need for another go further. If this is true, then we just return array of I, array of I, and here our brute force will end. And we will see in code. Now our this brute force approach take big of n square, which is a very big time. Here's our lead code problem 169, and here we will approach brute force. For that, first we take the size, the synapse dot size, and then for loop for int I is equal to 0 to n 0, I less than 10, and I plus plus, and we'll take frequency or count. So you will count, and count will be initialized by 0, and then in our for loop int j is equal to 0, and j less than, and j less than n, and j plus plus. Now we will check out if condition if nums of I is equal to nums of j, then count. If this match, then count plus plus, and after coming out from for loop, we will check another if condition if count greater than n by 2, n divided by 2, then return nums of I, else after completing the loop just return 0. Now let's run this code. There is a small mistake, and this is our solution accepted, and we submitted the code. So now we will use our optimal solution. In optimization, we will use sorting. First we will use sorting, and second then we will use linear operation. In sorting, it will take n log n, and linear operation it will take n. So overall time complexity will be of n log n. Now we will see how we will approach. First we will sort our array, which is inbuilt function. So sort array dot begin and array dot end. After sorting this, we will calculate size of n or size of array in array dot size, and then we will take count to store the frequency. Initially we will keep the count 1 because for the first element, suppose this is our sorting array 1 1 1 and 2. This is our sorting array. For this first element, we will keep our count is 1. So we just keep our count 1, and then answer. In answer, we will store our first element. So nums of 0, and then we will use our for loop for int I is equal to 1 to n minus 1, and then check if nums of I is equal to nums of I minus 1, then count plus plus, then increase the count if this match, otherwise otherwise count will count will be 1, means if we reach at 2 and that time nums of I will not match with nums of 1, so that time we again initialize the count 1, and in answer we will store the nums of at that index value, so answer that time will be 2. This condition will reach when the 1 is less. Suppose, for more clarify, I will take this example 1 1 and 2 2 2. Here it 1 is the less element, if you say, then when that time this condition is fails, so at current this is our I, so we will check if I is equal to I minus 1. No. So what will be happen? Then at count we will again initialize with 1, and at answer place we will take at that places element which is I, so nums of I, so answer will be 2 that time, and then again it will check if nums of then I will be shift here and I minus will shift here. This again true, so nums will be 2, and after this I will be here and I minus 1 will be here. This is true, so 2 will be 3, and then after completing this it will out from the loop and it will check the count. So what will be next? So our next here answer is equal to nums of I, and after completing this else there will be a check if, but we didn't out from loop, this will be in loop. If count is greater than n divided by 2, then we will answer return answer, and here we out from loop and then also return answer. This is our full optimization pseudocode. So now run this code. I just modified our previous brute force approach. Here's the end, and before that I will sort our array nums sort sort nums dot begin and nums dot end. After sorting this value, we just calculate our size. Then we will store our answer in answer. We just store nums of 0, and then there will be a count. In count we will store the 0 not 1, and loop will be start from 1, and this inner loop will be out, and here our if condition. If nums of I is equal to nums of I minus 1, then count plus plus, else count will be initialized by 1 and answer will be newly evaluate of I at that current index, and then it will check if count is greater than n by 2, then return answer, and at 0 return, this will also be return answer. Now let's run this code, and this is it successfully pass our test case, and now submit, and this is accepted, and you can see our time is take very less 3 milliseconds. In Mode's algorithm, its intuition is if we calculate the majority element here, then if the if we get the same number, then we count plus plus for same element. If we for different elements, we will count minus minus. Let's understand with an example. For example, this is our 1 1 1 2 1 2. This is our example, and at first for this index our count is 1 for this ith index, and when we will shift this, our count will be increased by 1 because this is the same element. I is equal to I plus 1, and then after incrementing here, sorry, this will be 2, and after incrementing here 2 will be increased by 1, so it will be 3, and then after incrementing I again, here I is not equal to I plus 1, or I is not equal to our answer, so this will be 2 because minus 1, and when this will be here, our count will be increased by 1, so it will be again 3, and when I will increase I 1, so then this 3 will be 2. After completing this, we will check if our count is greater than n by count is greater than 0, that means our answer is equal to nums of I. Our answer is equal to nums of I. There is another example. Suppose now we will see the pseudocode. And so for pseudocode, for int I is equal to 0 and I less than 1 and I plus plus, and then there will be a integer of answer. In answer, and initially we will answer the 0. Let's shift this here. Now answer is 0 and there will also be a count for storing frequency. And first we will check if count is equal to 0, then in answer insert the nums of I, and again we will check if answer equal to nums of I, then count plus plus, else count minus minus, and the end of this code just return answer. This is our main logic of Moore's algorithm. Now we will see with this pseudocode with the example. This is our example, and here is 2 2 1 1 1 and 2, and we will maintain two integer. One is answer and another is count. First count 0, answer is also 0, and this is our ith index. Initially I0, and it will check if count is equal to 0, then in answer nums of I, so this will be 2. Now check if answer is equal to nums of I, yes, then count will be 1. Now I will be incremented and it will again check count is 0, no, so it will go to next statement. If answer means 2 is equal to nums of I, yes, then count will be increment and I shift. Again check count 0, no, and next statement 2 is equal to nums of I, no, so count will be decrement. Again check, then I shift, and it will check count 0, no, 2 is equal to nums of I, no, so count will be 0, and I shift. Now check if count is 0, yes, then answer will be 2. This 2 will be 1 because answer will be nums of I, so it will be 1, and then check 1 is equal to nums of I, yes, then increment 1, then it will be 1, and I shift. Now it will check count 0, no, answer is equal to nums of I, no, then count will decrement, so count will be 0, and again it will check, then and I will be shift here, then it will check count is 0, yes, then answer of in answer nums of I will be insert, nums of I means 2, and then check is answer is equal to nums of I, yes, then count will be increment by 1, and then I is finish in -1, so now it will be out from loop and then return answer which is 2. So this is our sudo. Now let's run this code. Now I will just modify our previous code. So here I will delete the sorting, but size of in will be remain, and there will be a count, and count will be 0, and answer will be also 0, and loop will be starting from 0, and first it will check if count is equal to 0, then in answer we will just put the nums I value, and then it will check if answer is equal to nums of I, then count will be plus plus, else count will be minus minus, and the other part will be deleted. And now let's run this code. And here this accept our code. Now submit, and it takes 0 millisecond, and this is our base case, which this algorithm takes big of n, which is a good solution. Thanks for watching this. If you think this is helpful, then subscribe my channel and follow.